Welcome back. It's Orville Cota presenting to you all how to prepare a PCB using KiCad. We have already completed the first two stages, that is preparing a schematic and also giving the dimensions of the devices. Now the third step involves creating the front and the back side of a PCB. So you click on it, it will show an error, neglect it. What we do is the netlist that we created, we load it. So read current netlist and then close. If you notice, you can see the components have come. Zoom and you can notice. So to get them in the page, drag, select, just leave it. You don't have to click. No, then click to place it. You can see I placed it in the page. The page is the same one, rack with A4 size and the date. So now we have to arrange the components such that no two connections are overlapping. Now to move, as I told you all, just place your pointer above the device and click M. You can move it. You can see the connections are visible and then click it. Again move, click it, move, click it, move, click, move, click, move, click, move, click, and move and click. This is CP1, the input terminal. I place it on the left. CP2, the output terminal, the diodes, capacitor. Now to rotate, they just R, right? You want to see the connections, click on manual and automatic. You can see the connections. On the capacitor, I move it and rotate at the same time, so it works. Now the output resistor, let's move it close by and rotate it. There we have the rotation. The diodes, we rearrange them. D1 we move it over here, D2 move it over here, D3 and D4. I can actually rotate it there and rotate it. The input connector, move it, rotate if necessary, place it however you want it. Moving is good, right? Can leave some space just for the beginning, for the learning purpose. And now you see the connections. If you see the connection shouldn't cross. The connection shouldn't cross. They should be individually connected to each other. So now for this, let's do a little bit of adjustment. Let's rotate it. There. We'll rotate the capacitance too and the connector too. Now we see. Now you can see that all are connected without crossing each other. The measurement should be in millimeters. The grid 0.27. If you want the grid, you can keep it, otherwise it's your choice. Now again over here we have to create the tracks on the back side. The back part of a PCB, the copper part that you can see, the lines, those are known as tracks. So in the main menu over here, we select the back part, go to add tracks and wires, select, and now when you select, you can see wherever it needed to be connected, a yellow is shown. Before that, I will show you the design rules. In design rules, a window like this will open. Clearance. Clearance is the distance between any two connections. We will give it as 0.5 millimeter. Track width, how thick you want the track. I'll give it as 1.5 millimeter and then say OK. Now I'll give the track and I'll show you. You can see it's become a bit bigger, right? So now you can connect it like this, and then connect it. It's not connected, so I reconnected there. And for this I connected. Since this is the back part, it doesn't matter because this is the back side of the PCB. There, connections are given. Okay, it says that these two lines are not connected. So what I, because a line is shown over here means that it is not connected. So what I do is I erase that line and I reconnect it. So for reconnection, just take it, reconnect it. There, now to the line is there. We'll see. Next, I connect this one. I connect it. There, and the rest of the connections. Just move it a little bit with the arrow. Move it a little bit and then give the connections. Later, it's very simple. There, and another one that will left which is connected. So now if there are any connection errors, we can check them out by performing design rule check. You start design rule check, unconnected, because it shows one pad is unconnected. You check which one is unconnected. It shows that this one is unconnected. So what do we do is we reconnect it. There's no option, but we have to reconnect it. So there, we reconnected. Give the design rule check. Start, connected again. It says that it is unconnected. So what can be done is try connecting it again. There, give the design rule check. There. Now we can see that all the connections are connected properly. This is the back side. You want to see the circuit in 3D view, 3D display, and you can click and you can zoom and you can see the back part, how it is connected. Now let's give a little bit borders and stuff like that. For that, we go to the main menu, we give PCB edges. Let's giving a border, add a graphical line. You can always use the tool for your convenience. Click, come down, click, whatever distance you prefer. And then to finish it, press escape. Done. The borders are done. If you want to measure the dimensions, what are dimensions? For that you give add dimensions. If you are uncomfortable, you can remove this. Add dimensions, measure. It's 82.55 millimeters, that is 8.2 centimeters. So again, another dimensions. This is very useful when you're going to cut the PCB. Now we give the front and the back of a PCB. We can name it. We can give commands. For that, commands and add text. Now add text in the front. So I type, it will ask for the text. I give a text, I'll give it as, I'll call it name RCT. I'll give it in caps, better, RCT triple E. Dimensions you can vary as you want it. Orientation you can vary. For me, I place it over here. You can see it very well. Now I'll give it for the back side. Text. I'll give it for the back. Again, RCET triple E. Dimensions orientation is your wish. I give it over here. Now I'm going to show you all how it's going to look in 3D. You can see in 3D the connections. This is a pin array, the input, and this is the output with a square as the positive terminal. This is the front part, this is the back part. You can see it. Now, many places we require the pads to be a little bit bigger. So just right click, select the pad, edit, and then I'll change it to 2. Enter. Okay. You can see it's become a bit bigger. The same, follow it to all. So there is no common procedure for all. You have to do it manually. This is the drill point. What is the size of a drill? The hole in between. So actually do it for all in a similar way. Enter. Edit pad. Enter. Edit pad. Okay. Edit pad. Okay. Now this is for the connector. Edit pad. We'll give it as 1.5, which is already there. I'll make it a little bit bigger. It's actually not, I can't do it a bit bigger because you can see the clearance that is there, the 0.5 clearance that we gave. If I make it more bigger, it's going to clash, so I won't be able to give this. So in the others, we will give the editing. Edit. Press 2, enter, 2, enter. Okay. Edit. And then 2, enter. Okay. The same procedure for all. Two millimeters. You have to follow this manually because there is no automatic procedure like the annotation. So I guess all are covered up. Yeah, all are done. So now while saving it, you plot Gerber file. Plot Gerber file in KiCad. We use Gerber format. Plot format is Gerber format. We give plot, we save it, and then we quit. Now the final step for this is, once the Gerber files are created, we go for the final step. Let's view Gerber files or the printing procedure. Click on it. It opens. File. Load Gerber file. Wherever you have saved it. You have saved it on your desktop as a regulator or rectifier. In the back part. See, the back part is going to come like this, where your tracks are present, so that whenever you print it, you can directly get it on the PCB, which is shown in the next video. I move it. If you want to save paper, you can do it. File, append Gerber file to the current layer. Select the front, open. There you get a front component. Is that good enough? Yeah. See the diodes, input, output, capacitor, resistor. The same output, capacitor, resistor, the diodes connections and the input. So thanks for being with me. Once again, I'm Orville Cota, www.orvillecota.webs.com. Hope PCB is very useful for you all. It's an open source, it's a free source. You can do a lot with it. Only limitation is it's limited to single layer PCB and 2-layer. Multi-layer is not possible by KiCad. So hope you all make good use of it. Once again, thank you. Have a nice day.